Hi, and welcome to Master Data Pipelines, Unlocking Value with Splunk Federated Data Management. Now, before we dive into the content today, I just wanted to remind of any forward-looking statements that we might be making today in today's presentation. It's based on future predictions that may or may not change in the future. So please just be mindful of that as we go forward. Just to introduce myself, my name is Courtney Wright. I'm Product Marketing Manager for Splunk Platform, and I'm joined here by my co-host, Joseph.
Hello, everyone. Welcome, and I'm Joseph Kandatul Parambal. I'm a Principal Technical Marketing Engineer here at Splunk, and I focus on platform. And I'm really excited to talk to you guys about this topic today.
Awesome. All right, so let's get into what we'll cover today with the agenda. So for today's conversation, what we want to get into is really unpacking what does it mean? What do we mean when we say Splunk's federated data management capability set? And we'll unpack some of those key use cases where that might make sense for you. And then we'll spend some time getting into demos of actually building pipelines using Splunk. And then I'll leave you with insights into our latest research called the New Rules of Data Management. So let's just get right into it. So we get it. We're living in an unprecedented time where data growth is growing faster than ever before. IDC predicts that there will be in zettabytes of data generated annually by 2025, and that's doubling every few years. So we don't anticipate this pace slowing down anytime soon. And it isn't just the volume of data, right, that's challenging. It's complexity related to the variety, the veracity of data as well. And that's just creating this perfect storm of data management challenges. What used to be a technical concern has been more of a boardroom issue where we're seeing poor data management challenges directly impacting enterprise level concerns like increased risk, reduced agility, and overall missed opportunities. In the research that we did a few years back, the cost of downtime, we learned from that report that according to C-suite leaders, data sprawl is cited as the #1 challenge to managing downtime, where the average cost annually is about $200 million. For the Global 2000 organization on average. And that translates into about $4.9 million each year just to manage a data breach. We recently launched a new report on data management specifically, where we surveyed over 1,400 IT, engineering, cybersecurity experts from all around the globe. And across many verticals. And we learned that 91% stated that they spend more on data management this year than ever before. And on top of that, 62% claimed that difficulties with their data management strategy resulted in compliance failures. So we get it. We're living in this era where it just doesn't make sense anymore to consolidate data or to ingest it into any one platform. It's more of an ecosystem play. So here at Splunk, we're advocating for this move to federated data management. And I'll tell you why. So the goal here in federated data management is to really maximize the value of your data, regardless of where it lives. And there's a combination of practices that enable you to really do that well. So at Splunk, we believe that we want to enable you to control your data pipelines. The inability to structure your data appropriately for the use case or enrich its context really inhibits the effective consumption and usability of that quality data. And effectively, it slows down the ability to optimize your search performance. So we want to give you that control so that you can better manage your workload capacity. there's choice in data access, right? So as security data, observability data becomes increasingly decentralized across different storage locations and tools, the ability to securely access data regardless of where it lives means that you don't have to force fit it into a centralized repository just in order to apply the analytics. So we want to give you greater choice in how to access that data, and of course where it's stored. And then of course the elephant in the room is around cost, right? We need to be able to do this cost effectively. So having that flexibility and cost to streamline the data pipelines, align the data according to how it'll be used, and then of course managing that data across its life cycle. It's the combination therein that'll help you to achieve that cost optimization. So let's unpack that a little bit more and talk about Splunk's specific solution. First, starting with data management. By unifying all the data management capabilities for metrics, events, logs, and traces into a unified control plane is what enables our customers to really get the most value out of that data. So combining our traditional universal forwarder based data collection with more open telemetry based data collection. And specifically with our data management portfolio of offerings, think ingest processor, edge processor, right? So customers can filter, mask, transform data effectively, whether it's at the edge or within the cloud prior to it being indexed into Splunk platform. And depending upon those use cases and how frequently that data will be searched, you can have your choice again in how to route that data, where to route it to the most appropriate destination, whether it's the Splunk indexes or to an external data lake, again, with that cost and that compliance in mind. And we're building on this. We're innovating on this all the time. And in the future, you should expect to see more AI, ML being built into those workflows. All right, and then when we unpack federation, what do we mean by that? Federation meaning that the data is distributed, right? So customers want to be able to access the data in more performant ways in order to apply those analytics and the data visualization that Splunk is well known for. So this is something that we have delivered in market over the past few years, building out not only the ability to search across your Splunk environments, but also across third-party indexes, specifically Amazon Security Lake and also Amazon S3 buckets. So we're creating this path where you can tap the data more frequently before it goes into archive, knowing that there will be some performance trade-offs, again, fully in line with the use cases that you're driving. So these releases, this innovation has come to market more recently, and there's just so much more that I can't wait to tell you about in the future. All right, and I won't belabor the point. The key capabilities of our federated data management offering are here on this particular slide. Effectively, it's around filtering that data, getting it into the structure that works best for you, obfuscating that sensitive data from events before sending it on to different destinations, routing the data, onboarding new data sources with less risk, and then effectively optimizing for the monitoring and transformation of that data into whether it's from logs to metrics or into an appropriate structure that works best for you so that you can search effectively and, of course, apply those analytics so that you can get access to the right data at the right time that you need. Now, I'm going to stop there and hand it back over to Joseph so that we can really get into demos and you see this in action. Joseph, over to you.
Awesome. Thank you so much, Courtney. Up until now, we saw or we heard why data management is such a big topic today and why is it important, right? And in order to keep up with the market and also stay ahead of our competitors, we want to be able to build a solid data management strategy. And let's take a look at how Splunk can help you with that and work with all these different capabilities that Courtney just highlighted. So if you look at my screen right now, this basically shows the layout of what my demo would look like. So the data flow basically starts from Cisco ASA, where your Cisco ASA firewall logs are being generated and being forwarded to a Splunk forwarder. And then I have the edge processor that we have that processes your data at the edge. And in the edge processor, we'll be building those pipelines to process your data and then send it to Splunk Cloud. Now, I'm going to keep this demo for fairly simple, especially for folks who are new to this as a concept where we are not familiar with SPL2 code. So I'll just be using the UI to create those data pipelines and send that data to Splunk Cloud. So let's jump right into it. I'm going to share my screen right now. All right. So I just wanted to confirm that you're able to see my screen. Looks like it's on. So what you see on my screen right now is the UI for data management. Now, I want to highlight some of the key areas of this homepage so that we are all familiar with where we are navigating as I go through this demo. First is the pipeline. So pipelines are basically where you will provide instructions on how we want to process your data when it's incoming. So in that diagram that I just showed for this demo, I'll be showcasing how you'll be processing Cisco ASA logs. Now, data management offers two different capabilities. That is two different product lines. That is edge processor as well as ingest processor. So edge processor is what we'll be using for this particular demo. And an edge processor basically processes your data at the edge. And ingest processor essentially processes your data closer to Splunk Cloud. And the last thing I wanted to highlight was the destinations, where you basically can add destinations where you want to route your processed data to. So today, Splunk offers Splunk Cloud and Splunk Enterprise as one of your destinations, Amazon S3, and Splunk Observability Cloud. So I just wanted to quickly touch on how someone would actually implement an edge processor. Essentially, what you would do is you would go to the edge processor page and click on New Edge Processor. You can name your edge processor, and then basically you just have to provide it a default destination on where you will want to route the data that is not being processed. So you can either choose to either drop that data or send it to a default destination. So I have two different destinations configured here. I can either send it to Splunk or I can send it to Amazon S3. So let's say I choose Splunk as my default destination, and you can actually ingest or receive data from three different sources. That is, one is your Splunk forwarder. So Splunk forwarder supports a plethora of protocols as well as many different ways of onboarding your data. Once it comes to the Splunk forwarder, it can directly be sent to edge processor. And on the other hand, you can also send data directly through HTTP event collector or syslog directly to your edge node. For this demo, I'm just going to use the Splunk forwarder, and this is just to show what installing an edge node would look like. So if I go ahead and hit save, it basically will provide you a script that you will be installing on your edge node, where you can just copy the script, install it on a Linux box that is closer to your data source or your forwarder, and it will start transmitting data through your edge node. Now, for this demo, I've already installed an edge node, so I'll just be using that, which is over here that's highlighted. So now let's dive into how you can create a pipeline in our data management. So in order to create a new pipeline, you can use the new pipeline button on top of the UI, and then click on Edge Processor Pipeline. Here you will see that you'll notice that there are several different templates that are baked into the product, and I'll talk about it a little more after this demo. But for this demo, I'll start with a blank template. These templates are essentially just a starting point to or baked in SPL2 code that you can just use to build your pipelines. So let's start with blank pipeline here. And then since we're using Cisco ASA logs, I'm going to be using Cisco, the source type as my partition, and use Cisco ASA as the value. So partition essentially tells a user tells the edge node which data to process. So you might have 15 different data sources coming in. A partition would tell which data to act on. So here I'm picking the source type and giving it that Cisco ASA value. Next, I can upload some sample logs that I have to of Cisco ASA. So I just uploaded those sample ASA logs, and now I can basically use those logs to test my pipeline. You can also select a default destination. So in this case, I'm going to be selecting Splunk as my default destination. So now that we have pre-configured our pipeline, we are ready to actually write the instructions on how you want to process the data. So what you see on my screen right now is the pipeline editor. So over here is where you will write the code for it. And mind you, we'll just be using the UI to build this pipeline. And in the bottom, you're seeing the preview of our data. And then we'll be using a lot of the action tabs to actually take action on our data. So here, if you notice, I have a timestamp right in the beginning of my log. So I will basically extract the timestamp first from my logs. So to do that, you basically use the Actions tab and click on Extract Fields. So what you'll notice here is that it is asking you for a regular expression, and we have several regular expression libraries baked in. Now that we are essentially just trying to extract the timestamp, you can use many of these built-in functions that are available. So in my case, it's month, date, and time. So I'm going to use that regular expression. Now you'll notice that those timestamps have been highlighted, and I can give my timestamp a name, something similar to time. I'll just use timestamp as my string. Now, if I click apply, what you'll notice is that it will add an additional column in your preview where it's extracting those timestamps, as well as it'll add a field on the right side. So now I have the timestamp. Next, you'll notice that I have an IP address right next to it. So let's go ahead and use the same methodology to extract the IP address. So I'll be using the same library that I have, and I will basically select the IP address extraction regular expression and rename field. So the IP addresses have been highlighted, so I know that it's working, and now I click on apply. Similarly, a new column has been added and a field gets added to those IP addresses. Now that I've extracted these two fields, that is the timestamp and the IP addresses, I would like to select this particular string and then trim until this particular string. We've trimmed the logs up until that point. Next, I would like to extract the message ID so that I can take some actions based on the message IDs that are being generated in my Cisco ASA firewall environment. So let's do the same again. Go to extract fields, and then the message IDs essentially are just integers. So I'm just going to use that as the regular expression. So just basically use the int. So now that I have my message ID, there is another challenge that sometimes as a user I can see all these different message IDs, but there is only so much I can remember. I would like to have something that will explain me what these different message IDs are. So here is where a lookup table would basically come in handy, where I can use a lookup table to enrich the message IDs with an explanation. So let's go ahead and do that. So in order to do that, you're basically just clicking on the column and then using the enrich function that is built into the UI. So once you click on that, so I have this particular Cisco message ID as the CSV file that translates each ID into an explanation. So I can go ahead and select that, and here I will be prompted with like the way I would want to translate the message ID. So I would use the message ID as the source, and then I'm adding an additional field called explanation. So now you will notice that each of the message IDs have an explanation right next to it. Next, I would like to filter out low value logs. What you'll notice here is that I have TCP/IP logs, which are not necessarily that important to be sent to Splunk. So what I can do is use the filter functions built into the product and basically filter out those message IDs. So you will notice that it's 30, 20, 15 is the message ID that has the UDP logs. So I would like to just remove those from my log stream. So if I just would highlight all the UDP functions right here. Now I would like to remove it. So right now it's including all of them. So I can go back and actually, instead of include, I will click on exclude. And basically that'll exclude the UDP logs from my messages. I also wanted to highlight there are several different operators that you can use. So depending on your use case, you can select those operators and how you want to filter your logs. Let's go ahead and click apply. Now I have the high quality log that I want to send to Splunk. Now there's one more thing you would notice is that the user IDs are in plain text, and I would like to mask those user IDs so that I can stay compliant. For which I can just basically use or just select that particular string and then click on mask. So when I do that, it will prompt me with a dialog box where it will ask me what to replace it with. But this would only replace one single log, and I want to make it more generic. So you can basically select the user ID and use the built-in library function, which is word, and replace that with something like hidden or any string that tells you that the username is obfuscated. So when I click apply, it basically will substitute those usernames with a string called hidden. So now we've filtered low value logs. We've also made some changes to our sensitive data so that it doesn't get into the wrong hands. Now my data is well prepared to be sent. What I have to do is essentially just save my pipeline. So I'll give it a nice name that tells me what this pipeline is doing, and we can just save it, and it will start sending data to Splunk. So it'll ask me if I want to apply the pipeline. Let's go ahead and click apply. And now here is where you will select the edge node that the data is processed, the pipeline is being applied to. Awesome. So that was a very high-level overview of how you would create a pipeline without using any SPL2 code. So as you use the UI basically will add the SPL2 code for you and make it very easy to get started with your pipeline building process. Another thing, I talked about templates when I was creating this pipeline, and I wanted to spend some time on what those templates are. Essentially, these are baked in or pre-built pipelines that you can use to implement, get started on your pipeline implementation. So for example, we looked at Cisco ASA firewall logs. So I have a template for that. And we also have templates for, Palo Alto, syslog, Linux and Unix logs, Windows event logs, and we know how voluminous Windows event logs can be. So we have all these pre-built pipelines that you can just get started with. So what does this, if you want to see what this looks like, if you create a pipeline, you already have the SPL2 code baked into the product, as well as you can see that there's general recommendations on how you can filter out low value logs, and it has already narrowed down those message IDs for you. So if I definitely do recommend checking these templates out to get started with your pipeline building. Now, let me take a moment and basically switch gears and show a demo that's a little more advanced, where we talked about building a pipeline without using SPL2 code. But now let's use the same concept, but in addition to sending your quality logs to Splunk Cloud, we'll also do some logs to metrics conversion and send metrics to Splunk Observability Cloud, and then also send the low value logs to Amazon S3 because we want to save them for compliance purposes. So let's get started. So for this particular pipeline, I already have a pipeline built in. So we'll just go through the code for that pipeline and walk through each of the steps that the pipeline's taking. So you should be seeing my pipeline editor now, and I will condense some of my code so that we can read it, make it more readable, and we can walk through the code together and understand it thoroughly. So I'm going to comment some of these lines out so that we can see as we apply these different functions how the pipeline changes. So first, when I start the pipeline, it basically starts from $pipeline is where your pipeline basically begins. And here I'm calling the first function called extract useful fields. And that function is defined over here. So let's take a look at what this function looks like. So within this function, I'm essentially just using regular expressions to extract message ID and usernames so that I can take some actions on those fields as I go through my pipeline building process. And as I extracted those fields, you'll notice that those columns have been added into my preview. You'll also notice that fields are added over here. Next, I would like to basically drop some of the low value logs that are coming from my Cisco ASA firewall logs. So I've essentially implemented this function where I've identified low value log message IDs that I'm basically using the where command to just drop those logs out of my Cisco ASA log string. Next, just like we did before, we used an enrichment methodology using lookups to add more context to your data. So essentially, that's basically what I'm doing with this function here, where I'm using the lookup command and using the CSV file, I'm doing a translation from message ID to explanation. Now that I have the explanation and the message ID, I would like to start converting some portion of my logs into metrics. Essentially, I want to extract message IDs and provide a count so that I understand what is happening within my Cisco ASA environment. So what message IDs are being generated and what logs are being generated. So this essentially, the logs to metrics command essentially converts extracts message IDs from each of the logs and sends them to Splunk Observability Cloud. Now, when I hit preview, you will see that an additional destination is added. So if I click on that metrics destination, it will show me a preview of like what metrics is being sent. In addition to that, within the data management UI itself, you can actually preview what your Ollie output would look like within the data management UI. So you will see what that graph would look like. Now, you can also go to Splunk Observability Cloud. So based on the name that you've provided within your logs to metrics command, you can search that for that particular metrics. So if I click on chart and then look for Cisco ASA, and since that's the name that I've provided, it will populate with that particular graph. So if I do account and then do message ID, this will essentially provide a count of these different message IDs that are being generated in my Cisco ASA environment. Awesome. So now that we've looked at, or now that we've done logs to metrics conversion and sent those metrics to Splunk Observability Cloud, now I want to send the authentication logs to Splunk Cloud. So in order to send the authentication logs, I've basically identified message ID 109025. So I'll basically just filter on those message IDs using the route command and send only that portion of those logs to Splunk Cloud. In addition to that, you will notice that I'm also using a function called mask usernames. So let's take a look at what that function's doing. So essentially, it's basically using the username from the first function that we extracted and replacing that with name retracted. Now I can take this a step further and actually encrypt my usernames. So all I have to do is use the SHA-256 function and provide the variable username in it. And that will basically just encrypt all my username. And the reason why I do that is, let's say there is some threat investigation you need to do, and afterwards you want to decode who that particular user is. You can actually look at the encrypted user and have a translation layer being sent to S3 or your Splunk index and decode which particular user this is. So here you'll notice that the username has been encrypted, and you can always in the future decrypt that username based on if you're sending a translation somewhere to your Splunk index or Amazon S3. And now, in addition to that, I'm sending all the low value logs or the rest of the logs to Amazon S3, which is over here. So now let's take a look at the Splunk Cloud and make sure the data is incoming. So if I go ahead and click index and look for Cisco ASA index, this is where my the pipeline was sending the data. So you can see that the usernames have been retracted and only one particular message ID is coming into my Splunk index. And the rest of the fields are being indexed appropriately. Yeah, so if you look at the username here, there's only one value, which is name retracted. All right, so now we've looked at how you can use Splunk data management to actually selectively send logs to Splunk or Amazon S3 and convert logs to metrics and send those data sets to Splunk Observability Cloud. Now, you might be wondering, if I'm sending data to Amazon S3, what if I want to access that data sometime in the future where there is a reason for me? It could be for compliance purposes or forensic analysis and whatnot. So for this, Splunk provides a very simple, easy way for you to navigate that by helping you read data from Amazon S3. So this particular pipeline that we just looked at was sending data to an Amazon S3 bucket, which is over here. So it stores the data in a timestamp format, right? And then you can save them in JSON format or also Parquet. Now, in order to read this data back, I have to configure a glue table. The glue table basically will have the schema of the data. So I have the schema right here, and now I'll be using this to read my data back from Amazon S3, and mind you, without moving the data. So I'm reading this data in place. So in order to configure federated search for S3, all you have to do is go to the federated search section within your settings, and you can add federated providers there. So in order to add more federated providers, you basically use the federated provider button and add an S3 bucket there. I already have data for Cisco ASA archive, and I've created an index for that. So I'll be using this particular index to search that data back. So for this, I just have to use the SD select command and use that federated index name to just pull all the data. So let's go ahead and do that. So this essentially will just pull all the data as I'm using the asterisk here to from that S3 bucket. Now, let's say I want to search something more specific. You can use the where command and give it a particular message ID that you want to look at. So, for example, this one's 703075, which might be somewhere over here. So let's go ahead and just search it, and it'll match the events with that particular message ID and provide you an output. Now it's all SPL magic from here, where you can add basically use the regular expression to pull different fields from here and then create a table. So let's go ahead and do that. So essentially, at a high level, I'm extracting this particular message ID, and then using the regular expression, I'm pulling certain fields from that message, and then presenting those fields in a table. Now, if I want to use take it a step further, I can essentially, let's say I want to get a count of these IP addresses. You can use the the stats command to basically get that count of that IP. So there you go. So this, using the stats command, I'm able to get, how many times a particular IP address is showing in that message. So this is a fairly, high-level overview of how you can use federated search for S3. Now we've made several enhancements in terms of creating glue tables as well. Now for specific data sources, creating glue tables are automated, especially for Amazon CloudTrail logs. So in order to do that, you can essentially, you would add a federated provider and use the S3 bucket. And here you will see an option that says, I have you can basically check this box to automatically create those glue tables within Amazon. Awesome. I think that concludes my demo. Okay, this is another important thing that I wanted to highlight was we saw federated search for S3. It was essentially, data that's coming in from ingest processor or even other data sources. So you can read any data source back into Splunk Cloud. Now, if you're wondering how Splunk is able to do that without moving the data, so here's a diagram that basically explains that. So you can have data sources coming in from either Splunk, edge or ingest processor, or even ingest actions, as a matter of fact, or there will be other data sources that are sending data to Amazon S3, like your application, cloud services, and whatnot. So when Splunk sends the request to read a particular data set from a federated index, it basically passes that query to Amazon Athena. And Amazon Athena basically uses the glue table to pull that analytics, and it just presents those results back to Splunk Cloud without any data movement. All right, so that was basically the gist of how federated search works within Splunk. I also wanted to again call out the templates within our data management. Templates are basically the a good prescriptive guidance on how you can get started with your data pipeline building process, where we have pre-built code and great recommendations on how you can maximize the value of data. So be it logs to metrics conversion, filtering logs, or even reducing data volumes using lookups. So I do highly recommend checking those templates out. So in my demo, we took a look at how to process Cisco firewall logs, but there are several other examples that are available in Lantern. and and these are some of the use cases or problems or very common problems that we see our customers using data management for. So I do recommend checking these Lantern articles out. They are available in the Splunk Adoption Hub. So if you even Google data management Splunk Adoption Hub, they will take you to these links. So I quickly wanted to call out some of the recent feature releases that we've had in Splunk platform. So the number one is we introduced golden standard TAs recently. These are essentially TAs that follow the UCC framework, which is a standard framework that has been implemented in order to have good coding standards as well as documentation and testing so that the TAs can be well tested and maintained in the future. Right now, this is available for partners as well as Splunk trust members, and eventually this will be open to customers, but of TAs that are available to be used within the golden standard TAs. Next, we've added integration for Azure Event Hub within our data management, where you can onboard data using Data Manager from Azure Event Hub. Next, within our Edge and ingest processor, we've added capabilities to support Perl-compatible regular expressions. So this is something that was added just a few months ago. So this provides you flexibility with how you can implement your regular expressions within your pipeline building process. In addition to that, we've added resiliency queue or persistence queue, where let's say that your destination is not available for Edge or ingest processor to a certain limit, it'll queue the data up for you, and when the destination comes back up live, it'll send those data sets that are sitting in your queue to your destination. So it provides you a good amount of buffer to save your data or avoid data loss when your destination is not available. And within Edge processor, we have added support for onboarding data using Amazon Data Firehose. And something that's not highlighted on this slide is something that we released just yesterday, is the support to write in Parquet formats into Amazon S3 as one of your destinations. On the federation side, we've also made several updates. One is support for mCatalog. So this is for where we've made Titan integrations with ITSI, where we've added support for mCatalog, mCollect, send alerts, and send emails. In addition to that, for federated search for Amazon S3, like I said, we've added support for automated glue table creation for CloudTrail logs. Federated analytics is something that I didn't talk much about, but this is another capability where you can onboard or read data from your Amazon Security Lake. So in this, there are two capabilities that are available. One is you can read the data that's sitting in your Amazon Security Lake without moving the data, very similar to what we did with with Amazon S3, where you use the glue table catalog and read the data. Secondly, you can also onboard a portion of your data from Amazon Security Lake to Splunk. So if there is some data that you want to investigate that was ingested previously, you can onboard that data selectively, just a portion of that data, and add more context to your threat investigation. So I think that concludes my portion of this session. So I'll pass it back to Courtney.
Awesome. Thank you so much, Joseph. So guys, I teased out earlier this new research that we just dropped last week. It's called The New Rules of Data Management. We partnered with Global Research Institute, Oxford Economics, to survey nearly 1,500 professionals across security, IT ops, and engineering, just to understand what do they consider to be data management, and what are the main challenges that they're experiencing both at the enterprise level as well as technically in terms of as it relates to driving security and observability outcomes. So I encourage you to please copy the link here, do a Google search and find it and read it, because we also found some really interesting gaps in data governance practices that many organizations are contending with. But the silver lining is that we did identify a perfect trifecta of 3 specific practices that, when used in combination, deliver like far superior benefits than any other combination of data management practices. Plus, we identified 3 additional practices that are not widely adopted today, but of those select few that are using it, again, they achieved some significant benefits in terms of cost savings and also meeting those compliance and regulatory requirements. And then again, we're living in this era of AI, where AI accelerated innovation is contributing to the data management problem. So the research also gets into looking at the relationship between data management and AI, and vice versa, the impact that AI has been having on data management. All right, let's get into some Q&A. There are a couple of questions that I wanted to address live with you, Joseph, while you were giving the demo. So let's just unpack that right now. Is it possible to use Federation to search data in on-prem S3? Joseph, your audio is out. I think you might be on mute.
Sorry about that. I was talking on mute. So that capability of reading data from on-prem S3 is not available today, but it is a common request that we get, and something that we are looking into.
Got it. Thank you. Will the fields extracted at the edge processor become indexed field extractions when they arrive at the index tier?
Yes, absolutely. So based on the manipulations that you do at the edge processor, Splunk basically will index those fields. We just have to make sure it's compatible with the add-ons when you make those edits. But the fields do get indexed when it lands on Splunk.
Awesome. Those are all the questions that we have so far. I'll give it a 30 seconds if there's any more questions from the audience here. Okay, are ingest processor or edge processor available for on-prem Splunk environments?
So that is something that's going to be coming soon, but today the available option is ingest actions. So ingest actions will allow you to build rules on your data, and basically allows you to do a lot of the similar capabilities that I talked about, and process your data for your on-prem instances.
Okay, how about edge processor on GCP?
That is also on our roadmap. It's not available yet.
Yeah, sit tight for our customers that are on GCP or Splunk Enterprise. As Joseph said, we have a roadmap that is shaping up really nicely. So thanks for your patience. All right, let's move forward and talk about Conf 25. I know I'm so excited to be there. New city, I'll see you in Boston in September. Joseph and I will be there, and by then we'll have much more information to share with you about these releases and some of the questions that we've addressed today. Actually, there's another couple of questions that are coming in, Joseph. I think we still have a few minutes.
Yeah.
How does Splunk pipeline compare to Apache Kafka?
So I think I'll need something more specific. Is this about how Kafka streams data versus if it is, then so with Kafka, you're essentially creating these different uh, basically what do you call it, like different lanes to send data, right? But Kafka doesn't allow you to process your data on the fly. So with Edge and Ingest processor, you're able to create these data processing rules that allow you to be very, very granular to the character level on how you want to send these different subsets of your data to Splunk, to Amazon S3, to Splunk Observability Cloud, and we're working on adding more new destinations. So it provides you, like Courtney was talking about in the beginning, a full set of a whole lot of flexibility to process your data in order to maximize the value of your data within Splunk, and also make the data that's accessible, that's sitting outside of Splunk as well. Main goal is to ingest as much data as possible as the stream volume increases. So here it's more around processing your data before sending it to Splunk Cloud. So that is what I would say is the main difference.
Sweet, makes sense. Okay, and last question we'll take here for today. What kind of specs are we looking at for Edge processor? Can it replace multiple heavyweight forwarders?
Not today. So we do need heavy forwarders as we rely on add-ons, as well as heavy forwarders provide you a plethora of ways to onboard your data. Right? So it supports many different protocols, many different ways to onboard your data. And then once your data is onboarded, Edge or Ingest processor will help you process that data. Now, the capabilities within Edge is fairly limited in terms of using HTTP event collector or syslogs today. But in the future, it will look a little more condensed, I would say.
Thank you so much, Joseph, for sharing your expertise today. That brings us to the end of our time together here. Thank you guys so much for joining us today for our tech talk on how to master data pipelines with Splunk's federated data management capabilities. Again, I'm Courtney with Joseph, and it's been our pleasure. We'll see you guys, if not at Conf in September, we'll see you soon. Thank you.
Thanks, everyone.